Open source LLMs, copyright, and new architectures. The drive for fully open, copyright-clean AI models is gaining momentum, challenging not only technical boundaries, but also the legal and ethical underpinnings of mainstream LLMs. The LibreModel project stands out as a tangible example. Its author, Slime, trained a 960M parameter Llama 3 architecture LLM from scratch using exclusively public domain data, Project Gutenberg, Wikipedia, government reports, and more. Every code line, tokenizer, and checkpoint is released under the CC0 license, putting it squarely in the public domain. Practical limitations abound. Notably, the base model is near useless without post-training, and significant compute constraints shape design decisions. Yet the value for research transparency, ethics, and copyright squeaky clean commercial deployments is undeniable. Contrast this with the status quo. Almost every open model, regardless of its MIT or Apache license, is trained on a data soup few can vouch for. The AI and licensing debate lays this bare. Most commercially popular models in both NLP and vision domains are tainted by questionably sourced data, to the point that practitioners in the US/EU routinely treat indemnification, not legal purity, as the threshold for deployment. The hard reality? All training data is collected unethically, one user notes, and even massive companies have admitted to large-scale data scraping, personal info leaks, or questionable provenance. Legal action so far targets outputs that directly plagiarize works. The consensus is that, until regulators or courts force deeper accountability, what matters is the output, not what's in the training set. Against this backdrop, model building culture is shifting toward both ethical hygiene and methodological innovation. OpenDLLM, for instance, releases the entire lifecycle of a code-oriented, diffusion-based LLM, from pre-training and evaluation to inference and checkpoints, removing opaqueness often found in similar projects. Transparent releases and reproducible pipelines are becoming table stakes for researchers wanting their work taken seriously, especially in applied settings with licensing ambiguities. Efficient training, hardware limits, and system bottlenecks. Community-level R&D isn't just battling copyright, it's also contending with the hard ceiling of hardware and compute. Training even a modest LLM from scratch remains an arduous, failure-prone process, with cost and system constraints as constant companions. The LibreModel project's training relied entirely on free AWS credits due to personal income limitations, pragmatic but often less cost-efficient than using dedicated GPU platforms like Vast.ai. Restarts mid-training due to database errors or bad hyperparameters are routine. Tokenizer design, data cleaning, and frequent evaluations are crucial for quality. A single mishap in tokenizer preprocessing, like forgetting to preserve spaces, can tank output intelligibility, regardless of how advanced the chosen architecture may be. On the deployment side, the recent YOLO V10's hardware-aware study delivers a reality check for anyone benchmarking on powerful cloud GPUs, but deploying to laptops or edge devices. The researchers show that aggressively lowering input resolution, even by 100x, yields only slight FPS improvements on mid-tier RTX 4060 laptop GPUs. Why? The bottlenecks are not in flops or parameter count. They are in memory bandwidth, GPU scheduling, and thermal constraints. The implication is clear. Algorithmic optimizations alone don't guarantee practical speedups, and end users deploying AI in local, privacy-sensitive applications need to adopt dynamic, hardware-aware inference strategies. Their two-pass adaptive inference approach, which escalates compute effort only for difficult images, delivered a 1.85x speed boost over the early exit baseline with just a 5.5% loss in accuracy, highlighting that smarter system-level orchestration often trumps blind model pruning. Meanwhile, in the world of hardware acquisition, even finding GPUs at realistic prices is an exercise in skepticism. eBay listings for high-end cards draw community debate about scam risk, seller account vintage, and distinguishing server from workstation editions. Fans or lack thereof can make or break practicality. Despite strong buyer protection, the only universally recommended protocol is vigilance. Film every unboxing, even for trusted sellers, and never expect a 20-year-old account to have been aged just to scam a few $1,000s. Reinforcement learning and efficient reasoning in LLMs. Major advances in reinforcement learning for LLMs are upending the cost and efficiency dynamics of adapting pre-trained models to complex reasoning tasks. The Squeeze the Soak Sponge paper introduces the Remix framework, which brings true off-policy RL to LLM fine-tuning. Traditional on-policy methods like PPO discard previous rollouts at every update, wasting compute and data. Remix solves this by mixing current and historical rollouts within each policy update, using a blend of KL divergence constraints for both base and recent policies, then reincarnating, resetting the base model mid-training to consolidate improvements. The results are striking. Remix delivers state-of-the-art SOTA math reasoning on AIMA 24 and Math 500 with 450x less rollout data than prior methods, slashing both wall clock time and resource costs without sacrificing accuracy. Theoretical and empirical analyses expose subtle behaviors unique to off-policy RL, like bias towards shorter outputs, whipping effect, and the precarious balance between flexibility and stability. Efficiency gains are not limited to math. CognisQL R10 takes aim at the notorious difficulty of training models to translate natural language into SQL that actually runs and returns correct results. Prior text-to-SQL pipelines, often ensemble-based or agentic with multi-step reasoning, could attain 85% accuracy on internal tests, but only at unsustainable inference cost and fragility when facing open domain or complex queries. CognisQL R10 instead marries a single lightweight 7B LLM to a direct RL loop. SQL generations are executed and rewarded solely by correctness, +1, result alignment, MEGA1, or validity, NEGAS2, all trained using group relative policy optimization on a mere 4A100 setup. The result, 59.97% execution accuracy on the BERT dev set, outperforming far larger models, e.g. GPT-4, Mistral 123B, and dramatically increasing real-world feasibility for resource-constrained teams. Notably, careful prompt construction and sample quality were as crucial to performance as model scale or algorithm choice. Real-world AI utility and transparent evaluation. How close are leading LLMs to replacing knowledge workers, not on contrived metrics, but in the wild? OpenAI's GDPval sets a new benchmark. Instead of relying on synthetic or academic tests, GDPval measures frontier model performance across 1,320 real-world tasks from 44 major professions, from engineer to nurse to lawyer, with outputs graded by domain professionals. The results: top models like Claude Opus 4.1 and GPT-5 now match or beat median human deliverables in just under half the tasks, especially those that are repetitive, well-delineated, and knowledge-centric. While some may argue this still leaves human workers essential, the trend is unmistakable. Model performance doubles every major generation, and AI is already 100x faster and cheaper by API costs than the experts it mimics. Importantly, transparency and external validation are built in. OpenAI has open-sourced a subset of tasks and a public grading platform, inviting both scrutiny and collaboration from the research community. Caveats remain. These are one-shot, context-light tasks. But the implication is that the age of the knowledge work co-pilot is here and accelerating. AI agentic frameworks, monitoring, and real-world workflows. The agentic AI ecosystem is maturing, albeit in incremental, sometimes frustrating ways. Developers seek end-to-end frameworks for building, deploying, and monitoring multi-tool LLM agents, but discover that production viable remains aspirational for most platforms. Common pain points include unreliable tool integration, weak workflow transparency, model switching headaches, and inadequate logging observability. The practical consensus: heavy, one-size-fits-all agent frameworks are less useful than lean setups combining modular logging, Langfuse, LangGraph, or even hand-rolled and direct API calls, at least until mature orchestration emerges. LightLM, for example, can aid model handoff, but sometimes introduces abstraction overhead that negates its benefits if you're already API fluent. LangGraph and Langsmith offer decent monitoring, but still require a clear grasp of reducer functions and the patience to debug hidden states. Analysis of 1,000-plus agentic project schemas reinforces this reality. 3 dominant patterns account for the lion's share of practical agent deployments. Chat with data, 50%, business process automation, 25%, and tool-assisted planning, 15%, each with recurring pain points around workflow tracing, state management, and error handling. The take-home, battle-tested production agents are still more art than product, and monitoring logging strategy is not optional if you care about uptime or debugging. Multimodal and image models, local AI UX, and editing workflows. Multimodal AI models capable of processing or generating both text and images are attracting renewed attention, with users seeking fully local, uncensored, and creative flexibility. Yet technical and practical limitations persist. For example, Ollama users wishing for in-chat image generation alongside roleplay require distributed setups, typically a text generation LLM run locally, married to an external image model like Stable Diffusion. This orchestration can be achieved with front-ends like Silly Tavern or Open Web UI, but at the cost of increased complexity and resource demands, particularly on single GPU setups. Meanwhile, actual image understanding and editing tasks still expose the limits of even frontier models. Users report disappointment with ChatGPT-5's vision capabilities. Basic object counting and precise image modification, such as reproducing every ball and arrow in a football drill diagram, remain unreliable. Community advice, tongue-in-cheek, leans toward hire an intern with Photoshop skills when accuracy is critical or copyright is involved. More promising are specialized quantized diffusion models, such as Nunchaku's Qwen Image Edit, which offer image manipulation with compact models and efficient inference, although true perfection still requires manual QC. On the video front, ByteDance's Humo project pushes the envelope for human-centric video generation from text, image, and audio prompts, supporting nuanced customization and multimodal control. However, performance degrades for longer outputs, and robust local deployment remains technically demanding. On the research side, image-centric LLMs still struggle with cross-image information leakage in multi-image reasoning tasks, erroneously blending content across images if not explicitly constrained. The new focus decoding technique, requiring no retraining or architecture changes, mitigates this by masking all but one image per pass and combining outputs, yielding dramatic performance gains, plus 32 points on Vismin Bench, and making off-the-shelf models much less liable to mix apples and oranges. Developer tooling, debugging, and automation at scale. On the software engineering front, developers continue to seek tools that maximize productivity, reliability, and observability, yet simplicity reigns. Projects like FastAPI Radar provide real-time request exception monitoring for FastAPI applications with a one-liner install, underscoring that elegant, purpose-built debugging UIs often win out over heavyweight alternatives. For scraping automation, especially when dealing with bot detection, CI logs from undetected testing highlight the pains and workarounds employed to circumvent dynamic web page protections, e.g. carefully managing browser binaries and leveraging resilient PyTest setups for continuous monitoring. Even in hardware hacking circles, the maker ethos endures. Building a DVB-S2 satellite receiver from component modules, rolling your own Linux drivers, and swapping off-the-shelf NIMs for custom SDRs, software-defined radios, is a nod to old-school technical curiosity. It's a reminder amid the AI hype that some problems and joys remain orthogonal to cloud APIs and large models.